Over the past decades, scientists and astronomers have viewed the final frontier differently. They have always nursed the thought of alien life outside our planet and have worked towards confirming their existence. This has compelled scientists and astronauts to explore the final frontier by traveling out into space and seeing if they could find anything peculiar. Unsurprisingly, they did. The entire world of science and astronomy was in for a surprise when a NASA astronaut who had recently traveled to the moon took some pictures and discovered something bizarre while analyzing them. What did these astronauts capture? Could it be an alien spaceship spying on our planet? Join us as we explore how this NASA astronaut accidentally captured this while on the moon. With science and technology evolving, a lot has changed when it comes to exploring the final frontier in the search for alien life. Telescopes have been made, several satellites have been used to observe space relentlessly, and the outcomes yielded from these search missions are quite astonishing. An example of this happened when an astronaut took a picture on a space mission to the moon, only to see 3 dots as if in a triangular shape. These triangular shapes were quite distinct, like they were the headlights of some advanced technology spaceship. This discovery sparked controversy about the unsolved UFO phenomenon. Most reports about UFO sightings are often based on seeing a mysterious triangular-shaped craft primarily described in black, and from these descriptions it looks like the one accidentally captured by the astronaut. Reports of these strange crafts have been occurring on Earth for decades, but seeing such a similar craft in space blew the mind of astronomers, scientists, and even the defense departments in the United States. Regardless, it all comes down to one question. What are these crafts, and why are so many seen hovering or moving slowly before vanishing suddenly? It all started when reports about these unidentified flying objects began to make rounds across the media and could no longer be left as a rumor. Some sightings that were mostly reported were V-shaped, arrowhead-like, or triangular. After so many complaints, the US Air Force decided to look into these sightings. They named these UFO crafts unidentified flying objects. These reports rang through the 1950s, 60s, and 70s. In fact, one unforgettable moment during the Cold War in the 1960s was when mysterious flying triangles were reportedly seen flying over Georgia, Texas, Connecticut, and Pennsylvania. These sightings were strange enough until one scientist theorized the possibility of them being alien spaceships coming to spy on our planet before disappearing back. This thought motivated scientists and space agencies like NASA to put in more work in their search for extraterrestrial life. Scientists made some discoveries from their research and announced they had uncovered how to detect signs of alien life in space, with a prediction of encountering alien life forms by 2025. The space agency's quest to discover alien life prompted the discovery in space, and plans to track and find alien life have been actualized. NASA chief scientist Ellen Stoffen announced, saying there shall be strong indications of life beyond Earth within a decade, and concrete evidence will be presented within 20 to 30 years. The announcement was made during a panel discussion based on NASA's efforts to search for habitable worlds and alien life. "We know where to look, we know how to look," Stoffen said during the event, which was webcast live. "In most cases, we have the technology and are on a path to implementing it, and so I think we're definitely on the road," she concluded. However, hunting for signs of alien life is not an easy task. It is a more tricky proposition than observing potentially habitable environments. Still, scientists and researchers are working gradually toward that ambitious goal, with NASA kicking off its missions by launching a Mars rover, which is presently searching for signs of past life on the Martian surface and caching samples that could make a possible return to Earth for in-depth analysis. In the same vein, NASA also has plans to land astronauts on Mars in the 2030s. This step is what Stoffen sees as the key to the search for Mars's life. NASA also plans to go on a mission to Europa. The main goal of this $2.1 billion mission will be to find more details about the icy moon's potential habitability. Still, it could also search for signs of alien life. The scientists are figuring out ways to sample and analyze the plumes of water vapor that erupt from Europa's South Polar region. And the space agency's James Webb Telescope is also making rounds in its work. It observes the atmospheres of nearby super-Earth alien planets, searching for gases that life forms could have produced. but astronomers believed these tools would not be powerful enough to detect alien life forms, so they came up with something different, something that would be more powerful to become the James Webb Telescope's successor. As astronomers are always looking towards the next big thing that would make record-breaking discoveries in the world of science, scientists gathered themselves in a conference room to hear all about the machinery which would serve as a successor to the JWST. After being satisfied with the James Webb Telescope's success, NASA is now embarking on creating an optical telescope that would be big like the James Webb Telescope. However, this new telescope is going to have a different goal. It would look for signs of life on Earth-like planets, perhaps by the early 2040s. Mark Clampin, NASA's Astrophysics Division Director, informed the audience of scientists that only little details about the telescope have been finalized. Still, the news he gave was enough to excite them massively. Like the James Webb Telescope, its successor would also touch down at L2, a gravitational balance point 1.5 million kilometers from Earth. However, the new telescope would have some significant upgrades. Unlike the JWST, this new telescope would be designed for robotic servicing and upgrades, which could make it operational and serviceable to scientists and astronomers for decades, getting better as it ages. Since only a few details about the new telescope have been revealed, there hasn't been a dedicated budget. As a result, scientists like Clampin could not make much headway on the design and technology. But he devised a working name for the telescope, the Habitable Worlds Observatory. Scientists have been majorly happy about this new development, as their comments were joyful when they heard about the news. John O'Meara, the chief scientist of the WM Keck Observatory, was particularly excited about the update, with other scientists like Aki Roberge of NASA's Goddard Space Flight Center noted that serviceability would be huge in this new era. She continued further, this recent development creates a mountaintop observatory at L2. Like a telescope on Earth, the mirrors and structure can remain while increasingly sophisticated instruments are swapped. It's the instruments that make a difference, she concluded. However, the Habitable Worlds Observatory would not be NASA's next flagship space telescope after the James Webb Telescope. Instead, the space agency plans to launch the Nancy Grace Roman Observatory in 2027. The Nancy Grace Roman Observatory is a 2.4-meter survey telescope that will search for exoplanets and dark energy once launched. In the Habitable Worlds Observatory's case, the National Aeronautics and Space Administration is going through the top priority of astronomy's decadal survey. This community-led wish list guides lawmakers and funding agencies. The final survey report, published in 2021, was directed to NASA and implored the space agency to bring back its Great Observatories program. The Great Observatories program launched the Hubble Space Telescope and other observatories in the 1990s and early 2000s. The report said an $11 billion 6-meter telescope sensitive to near-infrared, optical, and ultraviolet wavelengths should begin the new Great Observatories program again. The report also explained further that the telescope, in addition to doing general astrophysics, must be equipped with the technology capable of detecting life forms on 25 nearby Earth-like exoplanets. This is the minimum number needed to determine statistically if life is common in the galaxy. NASA had also proposed to the Decadal Survey several options for the next big thing to be seen in space. Still, the Decadal report proposed something between NASA's proposals: HABEX and LUVOIR. HABEX would have relied on a 4-meter monolithic mirror, including a robotic starshade floating over 100,000 kilometers away and used to screen out the light of an exoplanet star so the planet could be spotted. LUVOIR, as big as 15 meters across in one configuration, was designed more as a multi-purpose observatory and would innovate on the segmented mirror technology used in the JWST. Although segmented mirrors can't create images quite as crisp as those from monolithic mirrors, they can be folded up, making it feasible to pack a far bigger telescope into a rocket fairing. As described, the Habitable Worlds Observatory contains no technology that has not already been thought about for HABEX or LUVOIR, says Scott Gowdy of Ohio State University, Columbus, one of the designers of HABEX. But Clampin noted that the agency would take a conventional approach to the Habitable Worlds Observatory to avoid the cost overruns and delays that troubled the James Webb Telescope. That project needed several unproven technologies which took longer to improve than expected. For the new telescope, NASA will take advantage of technologies already created or are currently being developed, including segmented mirrors such as the one used in the Roman Observatory's coronagraph and the JWST. In addition, it is an optical device within the telescope that bars the light of a star so that faint exoplanets nearby can be detected easily. It will also create a Great Observatory's technology maturation program to refine those technologies for the Habitable Worlds Observatory and conduct similar prep work for future Great Observatories. For example, because the Habitable Worlds Observatory will work with optical light which has a shorter wavelength than the infrared light JWST captures, the Habitable Worlds Observatory will require tighter control over the mirror's shape. It will need to be perfectly shaped down to a level of 1 picometer, contrasted with billionths of a meter for the JWST. The Habitable Worlds Observatory will also have to advance on the Roman telescope's coronagraph, which can block out the light of a star 100 million times brighter than its planet. The Habitable Worlds Observatory coronagraph must deal with 10 billion times brighter stars. One key will be suppressing stray light, which may require a cylindrical baffle around the Habitable Worlds Observatory, similar to the one surrounding the Hubble telescope. That would protect its mirror from micrometeorites that have already hit the JWST. Every pit in the mirror from a meteorite strike causes stray light. Some astronomers propose that a monolithic mirror with fewer edges than a segmented one would scatter less light, which might propel NASA toward a design more like HabEx. But Clampin-Say's recent research postulates that coronagraphs can also work with segmented mirrors. None of these are impossible problems, says O'Meara, a member of the Louvois team. He prefers a segmented design which permits engineers to make the mirror bigger if the science needs it without getting into the space constraints of a rocket fairing. Making it feasible to send service and repair missions to a flagship telescope also changed NASA. The Hubble telescope was serviceable but at a huge expense. Its repairs are usually done by Space Shuttle astronauts in low Earth orbit. Clampin-Say's future missions will utilize the wealth of private companies developing robots to help service NASA's Artemis program of lunar exploration. Robotic servicing is part of the architecture and philosophy for the Habitable Worlds Observatory, he says, saying that the extra distance of L2 is not a great challenge. As well as increasing the life of a mission by installing new instruments, as it was done for Hubble, servicing also permits flexibility in innovation. If one tool proved hard to get ready for launch, it could be installed later. Extending the life of a mission also looks better to funders. It makes it more palatable to Congress, O'Meara said, although Congress is maybe Clampin's first big challenge. Last month, lawmakers assigned $1.51 billion to NASA astrophysics for this year, a reduction of 4% from last year. Astrophysics was the only one of NASA's 4 science divisions to lose funding. Without funds to start GOMAP, Clampin is reprocessing some existing tech development funding to support small studies about the trade-offs of different designs. After that, he says he will combine with stakeholders to line up funding. That's a civil way of saying that for the Habitable Worlds to succeed, NASA and the astronomical community must get Congress on deck with the idea. Do you think the new space observatories would do better than the JWST? Let us know your thoughts in the comments section below.